Your integral career has already been launched, and I want to emphasize something that it seems like is just assumed that people know, and it's a very important fundamental about integration. And it's this statement: the integral of a rate is almost always something meaningful. You should chant that to yourself right now. The integral of a rate is almost always something meaningful. So I'm going to show you a couple of examples, and that might just be enough. And if you want to stick around beyond that, I'll show you some extra stuff. But by the end of this, you should be a firm believer in the integral of a rate is almost always something meaningful. So let's say that you have a equation, a function, that will tell you the rate at which rain is falling from the sky. Let's say we have a big old hurricane coming, and for each new hour, the rate of rainfall has increased. So at hour 2, the rate is 4. At hour 7, the rate of rainfall is 9 centimeters per hour. So if I want to know how much rain has fallen in total during, say, the first 5 hours, I integrate the rate. The integral of the rate of rainfall gives me the amount of rain that has fallen, because the integral of a rate is almost always something meaningful. Let's do one more. In economics, they like to make widgets. So let's say some factory is ramping up production, and the rate at which they're producing widgets can be modeled by this equation. It's an exponential equation, so that means the factory is increasing their rate greatly over time. Well, if I want to know how many widgets they actually produced, I will integrate the rate, because the integral of a rate is almost always something meaningful. So if I wanted to know how many widgets did they produce from hour 5 to hour 10 of production, I integrate from hour 5 to hour 10 the rate of production, and it turns out they created almost 22,000 widgets. You're going to notice that almost every integral problem we do has a rate that's being integrated if it's an applied problem. Now, if this is enough for you, then you're done with this video, but I'm going to show you a little support to this in the following minute or two. On the previous side, the very first example was integrating the rate of rainfall over the first 5 hours. And so here is the graph of rainfall, and this is the rate at which rain is falling. That's a better way to put it. And you'll see that the rain is falling harder and harder over time. That area trapped between the equation and the x-axis, that's the integral value, and in this case that area represents the amount of rainfall. So you could say, hey, that's a trapezoid, and I know how to find the area of a trapezoid, and I get 22.5 centimeters. That's the same amount of rainfall we had on the other side. That's if you got the answer via geometry. You probably haven't learned this one yet, but you're soon going to learn how to do integration by hand or by crunching the numbers yourself. Don't worry if you understand how you got that, but you get 22.5 centimeters. Well, I'm going to show a little bit of a unit analysis to support our result that this 22.5 centimeters is the amount of rain that's fallen. In the case of this function, the geometric region that we got was a trapezoid, but it could easily be a rectangle. It could be something that's not even a famous geometric figure. It could just be a squiggly line. Well, let's pretend for making this easier for our brains to comprehend, let's just pretend that that shaded area that you saw was not a trapezoid, but it was a rectangle. You would still be finding the area of the rectangle, just like we found the area of the trapezoid. But when you find the area of the rectangle, it would be a length times a width, length times width. If I do it just with units, which I think science teachers like doing this, a unit analysis, it's hours times centimeters per hour. When I do that, the hour in the denominator unit and the hour that's a numerator, they cancel, and we end up with just centimeters. And it's no coincidence that the answer to that integral was 22.5 centimeters of rainfall. The purpose of this last bit was to show you that the units support the phrase that the integral of a rate is almost always something meaningful, the units that you get are a clue to what that meaningful thing is. If that little bit of support in the last minute or two confused you, then just ignore it and go back to this phrase. The integral of a rate is almost always something meaningful. That will stick with you through the rest of the course.